Okay, so number 10, I'm in the opinion it is a bit tricky. Just looking at it, certainly you may not know what to do. It's nice to get a hint though, all right? So the hint I'm making is that you factor out a y on each of these equations. And let me just show you what I mean by that. You factor out y from the top equation. It's a common factor of y, by the way. What do you get over there? You would get y plus 4x minus 3 equals 42. And if you factor y out in the second equation, what do you get? You get 2y minus x plus 5 equals minus 10. All right? So let me just point out where this hint's given to you. It says one big trick is yes, you factor out y from both equations, and that's written right over here for you. And again, I actually believe in giving people hints sometimes, particularly if it allows them to move forward. Hints really only work for well-prepared people, though. Now, someone says, would you give an additional hint? Well, probably, all right? So factoring that out, and someone says, what would you do now? Well, I'm noticing what you could do is you could solve those equations for y now. Let me write what I mean by that. That if you did this over here, you could solve this for y, and what would you get? You would get 42 over y plus 4x minus 3. And the other equation, what are you going to get? You're going to get y equals minus 10 over 2y minus x plus 5. All right? Now, the point of this is you realize that these are equal now because both are y. So I would set them equal to one another, right, with the understanding that y is y. And what would you get? You get something pretty simple. Let me write that down for you. You get 42 y plus 4x minus 3 equals minus 10, 2y minus x plus 5. Then what would you do? I would say clear the fraction. All right, clear the fraction. And if you clear the fraction, let me just, what I mean by that, you'd get, 42 times 2 is 82y. Let's see, minus 42x plus, 5 times 40 is 210, right? Let me see if I did that right. 210 minus 10y minus 40x and then plus 30. Now, I realize some people wondering, how long did it take you to figure this problem out? I can't remember, but I'll be honest, they don't come to me immediately. I have to try different things. A piece of paper doesn't work out, try again. Piece of paper doesn't work out, try again. I try a lot. I'll be honest with you, I keep trying. I know they're doable, though. I would never look at a problem and say, I can't do it. Now, granted, you could get a dead end and not be able to do the problem. That does happen. Well, let me take a look at it. And, kind of moving things around. Let's see. And I'm going to say 92y. And then I'm going to do this over here, 2x. And let's see what I'm going to do. I'm going to say plus, let me write this down now. What do you get? 180, right? Wow, that's easy. And what do I mean by that? X equals something. What does it equal? It equals, let's see, 40. Did I make a mistake somewhere? Oh, I'm sorry, it's not 82, it's 84. So this is 94. Sorry about that. And I'm dividing by 2, so 47y plus 90. And I want to go back over here and point out that we've taken the road and we now know a relationship between x and y. Whoops, I did it again. We know a relationship between x and y. And that's useful. And someone says, why is it useful? We can now substitute it anywhere we like, all right? In other words, if x equals that, we can take that x to anywhere you like. All right, now someone says, where would you substitute it in? I'd probably go back to the original system and look at it. And I'm going to claim that, maybe plugging it in here might yield something that's pretty simple to come up with. Now, granted, it might have been a long road there, but y squared plus 4xy minus 3y is equal to 42. And I just pop it in, see what happens. All right, so I'm taking this, I'll put out what I mean by that, and I'm going to pop it into that equation. Now I'm going to start to erase things because I've taken a long road. I've gotten here. I want to continue. I don't want to look backwards anymore. I want to go forward. And things are written down. They're nice and neat to write. They're neatly written down for you as well. I'm just getting rid of my baby chicken scratch over here. All right, my baby chicken scratch. But all that, hinting at this led to this over here, and now I got a substitution to make. And let me write that down for you. And what do I got? I have y squared, plus 4. Well, x is actually 47, y plus 90, times y minus 3y equals 42. All right, now I got to do some work here. So what do you get? Y squared plus, let's see, 4 times 47, 160 and 28. 168 y squared I'm sorry, it's 160 plus 28. I got to pay more attention to what I'm saying. 4 times 47, 160 and 28. 188. Sorry about that. Plus, let's see, 4 times 90 is 360y, minus 3y equals 42. They're kind of nasty numbers, but let me just see if I get their result they say I should get. 189 y squared plus 357 y minus 42 equals 0. So let me point out they got there too. All right, 189 y squared, 357 y minus 42. Okay, so I'm at that stage. I got one stage at a time. Right, these I need to move forward though. So I got there, and it's sort of like this is the study. I'm studying my own work, and I'm really what we're trying to do is teach you how to study somebody else's work. You got to work step by step. All right. Sometimes you need help saying what'd you do here, what'd you do there. That's what I'm doing, kind of talking through it. All right. So what I got to do now is I got to factor that, and that looks tough to factor. I'll be honest with you. Now certainly if I was looking at 189, it's divisible by 3. So let me put that down for you. By the way, when I start with a number like 3, you may wonder why is that? It's easy, that's why. So that would give you 6, which would be 18, and then I get 9, so 63. And then I start to realize that 63, right? So 189 is 3 times 63. And again, I'm looking for factors, all I'm doing at this point, because I know I have to factor it. And this is 3 times 21 times 3. Right, so I'm going to say 189 has something to do with those numbers. Now, could you go further than that? Of course you could. 21 is 3 times 7. I might have to do that. But then I'm looking at, 42. And I notice 42 could be written as 2 times 21. So I'm hoping 21 has something to do with the problem. But now I'm looking at the 357, and I'm wondering, does that divide by 21? Well, let's do it. You get 21 here. That would be 4. That would give you 1, 7. And it looks like, yeah, it goes in 17 times. All right, now remainder is 0. So I'm pretty comfortable now that 21 factors out. Let me write that down for you. So 21, and let's see, that would be 9 now, right? So 9y squared plus 17y minus 2 equals 0. Well, again, let me get rid of my chicken scratch over just all my simple arithmetic problems. All right, I got this over here. And I got this. I'm done with that. All right. Now, the question is, can I get to the next step, which is factoring? 21, and I'm looking at this thing, and again, the hope is I don't have to go to quadratic formula, and I'm looking at that. I get the 9 and the 2 and the 17. And certainly, we talked a lot about the AC rule. I kind of like trial and error, so I'm going to say 9y and y. And 2, because 2 times 9 is 18, but I got to get a 17 and a minus 2. So I'm going to say this over here. But again, I'm not saying it's right. I'm going to try it. Let's give you 9y squared. Yeah, it worked nicely. 18 minus 1 is, it worked beautifully. All right, so now I know, at least I know what the y's are. So I want to, talk about the line that they got here. I'm kind of moving along, right? I'm going to get my eraser out. I feel pretty comfortable. I feel pretty comfortable that I can get there, all right? Given some hints, by the way. So the question is, what do you have now? Well, I got answers, and the answers are as follows. Y equals minus 2, or y is equal, and by the way, we're looking at this over here. I have answers. 1/9. Question is, what's the x? Well, I'm looking at this to get the x now. What's the x going to be? Well, let's do the minus 2 first. And minus 2 times 47 is going to be minus 94 plus 90, so x would be minus 4. So I have one ordered pair solution, minus 4, minus 2. And yeah, these are tough problems. I'm not saying they're not. And I'll do the 1/9 now. What's that going to be? It's more difficult. There's no doubt about it. So what do you get over there? You'd get x equals, and again, we're using this up here, 9 times 47. Let's see, that's 360. I'll write it aside for you. And 9 times 7, 63. And that's going to be 423. I got to be careful. Common denominator is going to be 9, right? And 9 times 90 is 810. That's a nasty looking number, isn't it? Now the question is, did I do it right? Oh, you know what? I made a mistake. It's not, I hate to, I see this thing and I know I made a mistake right away. Let me go back over it again. I'm sorry about that. I don't know what I was doing over there. X equals, well, it's 47 times y, and if y is 1/9, it's 47/9. And sorry about that. Plus, and it's going to be 90, and 9 times 90 is 810 over 9. And this is going to be x equals 857 over 9. Let me just look at the number. I want to see if it's divided by 3. 7, let's see. No, it's not divided by 3. So I'm not going to do any kind of division over there. So what do you get over there? You would get the number 857 over 9, and then 1/9. Right, a really kind of nasty number. But we get 2 points now. We got this point, and these are clearly being listed. I also want to claim I give you the graph, and it says figure 80 on page, yeah, it's right over here. Again, granted, the graphs, it's pretty easy if you know how to work a machine to get these points, by the way. What I mean, graphing it and then plotting the points. And you may be surprised by this, I've actually plotted the points that I got over here. Minus 4, minus 2. Let me point out what I mean by that. That's that point over there. And this point over here, it's kind of a nasty number, but it's still, you can plot it, 857 over 9, and then the other number is going to be 1/9. And I'm plotting them both, all right? Now, granted, tricky. So when I'm playing about tricky, people get stuck. I can't remember me doing this problem, though, but I'll bet you one thing, I did not see this initially. What I did was I had to work on it. I tried something, wasn't working, tried something, wasn't working, tried it. Unfortunately, I have no one around to give me a hint. No one, right? The only place I could get a hint is I could look back over Wells's work, which you should do, by the way, and see if you see a similar problem. That's one thing to do. Or just hack at it. Do you eventually stumble on a way to get a solution? Of course you do. And why is that? These problems are written to work. Keep working at it. In the real world, we don't know things are written to work, though. Here's the deal, though. We should still work on problems, no matter how difficult they are, with the assumption that if we continue to work at it, we will get it to work, all right? I don't care what the problem is. So, again, I want to remind you, my name is Ron Bannon, and if you're listening, this long, I think you probably know by now that I've been giving my email address out periodically for those students or teachers that need to reach out to me. Again, if I'm not overwhelmed, I'll get back to you. If I'm overwhelmed, I won't be able to get back to you. It's really that simple. Thank you for paying attention, though.